Question 14 says, in order to determine the depth of a well, a stone is dropped into the well and the time taken for the stone to drop is measured. It's found that the sound of the stone hitting water arrives 5 seconds after the stone is dropped. If the speed of sound is taken as 340 meters per second, what is the depth of the well? And diagrams always help us with our understanding, so let's try and draw a little bit of a well here. And there's my well. There's a stone, there's my stone, and it's going to drop down until it hits some water, which is down somewhere in the well. Go down there. Of course, when it hits, it makes a splash. That splash then makes a noise which travels back up to the person who hears it. So there's two things going on here. There's the time that it takes for the stone to fall to the water, and then the time for the sound to get back up to the person. So we have two different things happening here, but they are related. And we know in the relationship that the time that the stone takes plus the time that the sound, let's say n for noise, is equal to 5 seconds. And we also know that the distance is the same. The distance the stone falls is the same as the distance the sound travels. Okay, so we'll analyze one thing at a time, and let's do the stone first. For the stone, we know that the starting velocity is 0. We know acceleration is -10. That's all we know. But what we're interested in is the displacement, because it's going to be the same as the other displacement, and the time. And this is the time of the stone. All right, so which constant acceleration formula uses UAST? And that is S equals ut plus a half at squared. Okay, so let's fill in what we know. U is 0, so let's call S, well, S is the displacement. If we want to make it positive, it's going to be negative because acceleration is negative. We have to make the acceleration positive. Let's just keep it with displacement for a moment. So U is 0. We're going to do a half of -10, and that, of course, makes -5. And time, we don't know, time of the stone squared. That's about as far as we get. There's two unknowns there. There's the S and there's the time, or the distance. Right, actually, let's turn that into a positive distance. So it's going to be negative because we're making 0 where the stone is dropped from, and the stone drops down, which means the displacement is negative. But we're only really interested in the absolute value of that. So let's use D and say the distance is actually just 5 time that the stone travels squared, which actually looks quite easy. Let's go to the sound. So when the stone hits the bottom, the sound travels up. And it's traveling just according to the formula. Velocity equals distance on time. This distance is the same as the other distance, which leads us to distance is velocity multiplied by time. But they tell us that the velocity is 340, and so we're going to get 340 multiplied by the time of the sound, which we're calling Tn, the time of noise. All right, so we have three things here, and we're going to put them together to solve. Maybe the easy one first is if the Ts plus Tn is 5, then the Tn is equal to 5 minus Ts. So we can substitute that into the sound equation and get our distance is 345 minus time of the, not n, time of the stone. And that's a good place where we can put together the two equations. First one being the distance that the stone falls, and the second one being which is now the distance that the sound travels, which is the same as the distance that the stone falls, and they both have time of the stone. Right, so we're going to say that equation 1 is equal to equation 2 because they both have the same distance, and that just gives us 5 Ts. We don't really need the S anymore. Let's drop it. 5 time squared is equal to 340 times 5 minus, okay. Shall we expand the brackets? No, we won't, because we can divide both sides by 5 and hopefully it makes our life easier. And that looks like a quadratic that we have to solve at this point. All right, working this through, we're going to divide both sides by 5. T squared is 68 multiplied by 5 minus t. Expand the brackets. T squared, maybe we should bring things over as well. 68 times negative t is negative 68. Take it to the other side, it will become positive. So we get plus 68t, and then we've got 68 times 5 gets us back to 340, but it's positive. We bring it over to the other side of the equal sign, and we'll have minus 340, and that equals 0. We're not expecting nice numbers on this one, so let's go to the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, but we've got a negative there, so it's going to turn into plus 4 times 340. A is 1, divided by 2a, which is just 2. All right, that's going to give us 2 answers. When we add them together, we're going to get, time is 4.678, approximately 678, and or we're going to get t is negative 72.7. All right, we reject that one because it's not going to be a negative time, it's going to be a positive time. All right, so the time it takes for the stone to fall to the water, and that this is reasonable, it's less than 5 seconds, is 4.678 seconds. So how do we find the distance? The distance is 5 times the time squared, and that should wrap it up for us. And so the distance, which is the depth of the well, of course, I'm using the full value, which is on my calculator. And we get 109.4258. Let's just go 109.4 meters. And that should be the height of, or the depth of the well, as we call it.